Hey everyone, welcome to Python Mega Bootcamp. My name is Dev and I'm going to be your instructor throughout the course. I'm a Python and Ruby programmer in field of AI and an electronics and communication engineer. Now let me move towards the course. So it's a complete Python course that will make you very advanced in Python from a beginner. I interviewed many programming students to get what's required to teach. Many of you are thinking why I learn Python. Many are thinking I have to go for any other basic programming language like C first. And also those who are doing programming are maybe stuck in only college and school education and thinking how can I learn the programming that I can apply and build whatever I want. Then maybe you have to give a little time to check this course. This course is not just a course on basics and just concepts of Python. This is designed according to your need. We are going to build more than 15 projects to apply your knowledge in this course that are very basic from dictionary to up to real working games and big data projects. I have tried my best to properly arrange and build the course step by step according to a student's need. We will begin from learning the best editor for you to basics, then data analysis and visualization, and also the graphical applications development with working desktop applications. So it's hard to describe everything in introduction because there is a lot of here. One thing I'm sure about, after completing the course, you will be one with complete Python knowledge and you can easily build any application by your own. And also, I'm sure you are not going to regret being a part of this course. And also, for trying this course and giving your time to us, you can also take all the notes and course available here for free. So, have a look at this mega course and check the modules and content. I hope you like it. Learning by building is the best way to learn anything, because having knowledge which we cannot apply is of no benefit for us. When we learn something and apply them practically, we can take benefits of that. So in this course, we will just not focus on lectures and concepts and all. We will learn every concept and then build applications and programs that can help you to be perfect in that concept. Every section is designed in a way that you will get opportunities to apply all you have learned by building projects in every section. So I hope you get everything I teach here. But one thing, try to complete the full course so that you can take the maximum benefit from it. Hey everyone, so this video is about types of program and doubts in your mind. So first of all, we will consider the types of program. So before learning programming, it's better to know that how many program types are there. So first of all, if we talk about the most basic types, then we have three types of program. First one, that we generally write in our command prompt and terminals, which include the syntaxes and just a backend there. Like a one here, you write a program, you run that program, and that there will be all backend there. You also need to add something there, and then the program will work. Like if I write rock here, it provides me an output of meanings of rock because there's a dictionary actually there. But everything happening there is in backend. After that one, these programs are just there and they are for programmers only and mostly for practices. After that one, second type we have is the user interface programs, like the Atom, in which I am actually running my code. This one is a user interface program. Other example of this one are like this Caterpillar game. This one also is a graphical type of program because it has user interface. After that one, third kind we have are the web programs, like the Google. This one is a web application. Here you search something, click there and you get the output. Apple website, this is also under the web development. So this is the third category of programs. Hey everyone, in this video I will tell you that what actually Python is. And I will clear two most basic doubts in students' mind. First one is, I have no knowledge of programming. Maybe first I have to go for some easy programming language like C. But they don't know that Python is the most easy one. Second is that students is confused about learning Python. That why should I learn Python? So we will focus on both of these and on also that what actually is Python. So first of all, let me consider what actually Python is. So basically we have different levels of programming languages like low, machine and high. Low and machine are something that is easy for computer to understand but hard for programmers to understand. And high level is something that is harder for the computer to understand and easy for us to understand, because the computer just requires 0 and 1 binary digits, but the syntaxes in Python are in English. So that's why this one is known as a high level programming language. After that one, Python is developed in 1991, but it came in attention in 2012. So here I have a growth chart for Python, in which you can notice before 2012, this one is even lower than the C++. But then in 2018, Python is the most favorite and popular programming. So there is a sharp growth in Python programming, and there are various reasons for that one. Easy to learn, easy to work, and everything is available in Python. When you learn Python, you will get that whatever you want to do, there is a library, there are resources, and everything available in Python. Even the biggest companies in the world, Netflix, Google, they are also using Python. Even IBM is also using Python. And the concepts like machine learning, AI, they are very easy with the Python programming language. Because in the other programming languages, like in C, where you need to add the syntax of approximately 200 to 300 lines, will be written in Python for just 20 to 30 lines. And there are a lot of advantages to learn Python. So basically, Python is the best programming language available here. Now, just after the Python programming, let me consider the doubts in students. Like, I don't have any programming language knowledge. Do I have to go for Python? I don't have written any code before. Should I have to learn Python first? Or I have to go for any programming language like C, and then I have to go for the Python? So for all of these students who are thinking these kinds of things, in my opinion, every programming language is divided into two parts, out of which first one is the syntax part, which is different for every language. In C, you need to write very large code, but in Python, just few lines of code. Second thing, the logical part, that how you are applying your knowledge to solve your problems. That is same in every programming language. Whatever you have the syntaxes, in final, you are going to apply the knowledge same in every programming language. It's just like learning English, learning French, or any particular language, but their motive is same. Representation of your feelings, and how well you represent depends on your thoughts. So just like that one, we have the programming languages. So it's just the syntaxes that define different programming languages. And the answer for that question is, you don't need any programming language to learn Python or any kind of language. If you just go from the beginning to any programming language, you will find no issues, and everything will be same for every programming language. So whether go for Python or C, things will remain same. And being the Python best programming language, I suggest you to go for this one. This one is very easy as compared to C and other different languages in comparison of syntaxes. So you will not find any problem while learning the Python. And the course is designed in very systematic way, starting from beginning and then step to step, very advanced level. Now let's move to the second question. Why should I learn Python? So the answer for that one is because Python is one of the most popular language, growing everywhere, and the fields like machine learning and AI again require Python. And also, if you look at the salary growth, then there is a large growth in salary of Python. However, it is declining in the last year, but it's still increasing in field of data science, machine learning, and artificial intelligence. After that one, Python is very vast. You have different options there you can go for, and here is the salary analysis for these. So if you learn Python, then it will provide you benefits all around. You can even build your own programs, sell them. You can work anywhere in these fields. You can go for machine learning. You can go for artificial intelligence. So there's a lot more there. I hope both of the doubts are clear to you now. Hey everyone. Before starting the course and installing the items on Windows, there's a little video that how you can get the linked files and codes with this course. So you have a page like this one on which you are maybe watching the course, or maybe you are on mobile. Then just go a little down there. You will get these: about, reviews, community, project and resources. Go to about, and there you will find a drive link. Click to access drive. Just click on that one, and you will get a drive with different folders. There we go. So here we have basic Python and the part 2 and part 3 of this classes. So whatever the class you are in, just click on that one. You will get all the available codes, notes and resources with that one. Here we have different options, out of which, like first one, this editor.html will look like this one. They will get all the links to download the items, like download Python 3, just click on that one. You will be redirected to the page directly. Then we have notes, which will look like these HTML pages, in which you have everything properly explained with proper examples. So you can download these and use with the course. So this is about these things. Also, if you did not get access to Drive on clicking this one, you have a link here. Just copy this link, go to a new tab, paste it there and hit enter or return on Mac. Then you will also redirect it to that drive. So this video about these linked files, so that you cannot get any error or get any mistake with these files, because these files are not linked with the course. On here we have on this one. So these files are not linked here and not available on notes. So I have arranged all these files on the drive so that you will find this one very simple to use. So thanks for watching, and let me continue installing the Python and Atom on Windows. Hey everyone, in this video we are going to learn some basics of turtle graphics, that how you can draw some figures by using turtle graphics. So first of all, some sources of error you may get. First thing is, this one is a by default library, so you do not require to install this one. You just need to import this. After that one, you will get something like memory allocation error, did not able to create memory, and that is because of the database we have installed in the last section. Because of that one, that created separate windows, user or that PostgreSQL, due to which the turtle graphic did not able to find the actual location for its window, because turtle graphics require a window to create some drawings. So for that one, just uninstall the database for a while and install that one again. Now I'm going to prefer terminal for this one, because this is the best for explaining these turtle graphics, because they require something like creating drawings and moving the cursor again and again. So for that, this one is best. You can also use the Atom and Jupyter, they work same. Now first of all, I'm creating a Python shell with Python 3, and then you need to import turtle as t, and you can import this one with any name. Now few basics of that thing. First thing, if you need to draw, you require some any kind of paper or any kind of window where you can draw. Like you cannot draw in air, so that's the fact here. For that one, to get a window, you can run any turtle command, you will get the window. The most basic one we do for that one is goto command. So this command is something like, if I have this cursor and this one is here at this point right now, so it will be something from x-axis and something from y-axis, and that are the coordinates denoted by the pixels. Same here, this goto refers to moving this cursor to any particular position by using the coordinates. So if I pass something like here -100 and say -100, I will get a pop-up window with which I will get this cursor at this particular point, -100 and -100. So basically this was actually at this point, and it get -100 and -100 there by creating a line there. So this is the most basic command of turtle graphics. Without this one, if you did not pass the parameter, you will get error. Now if you change these values here, again this one, but something like say 100 and -10, it will get to that particular point as this one reached there. If I do here 200 and +10, I get here. So it will move according to you wherever you want to make this one. So this is the first basic command. Now after that one, this one is creating a line with this one. So what if I need to create something here that is with this one, but they are independent of each other, like there is no connection in between them. So how can I do that one? because the lines are there. So for that one we have two commands, pen down and pen up. So this state is known as pen down, in which I am writing a line with my motion. And there is another one known as pen up. So for that I just do t dot pen up and pass the parentheses and just hit return. And now if you move this one to any position, say t go to say 50 and minus 50. So now this is here without any line drawing here. So by using this one you can get rid of the lines if you do not require that one. And now if you again need the lines, you just do pen down parentheses and then hit return. Now if you draw any line, say go to 150 and minus 50, there we go with a line. So now we have line also. So this is how you can make line and get rid of that one. And if we talk more about this line, then you can also change the color of this line by just simply t dot color, and in that one pass any color, say blue. Now if you notice this one, this gets blue color now. And if I say do something like this one into 250 or something like closer 80, there we go, 80 this one, and this one say 350 or 250, there we go with a blue line. So this is how you can change the line colors. And after this one we have this one. Now if we talk about this line, so here this line is very slim. What if you need a thicker line? So for that one we have a command known as pen size. So t dot pen size, in which you need to pass any value, say I'm passing 20, hit return. And now if you make any changes to any position, say 50, 80, there we go, this one, a very thick line. You can again reduce that one to any, say 2. And now if you do another change here with 70 or say 30, there we go with a very thin line. So that is how you can create change the size of this one. After that one, few more basics like the speed of this one. There it is moving a little slower. If you have noticed there, like if this one is 350 and 30, so this one is a little slower. You can also increase the speed of this one by just t dot speed, and that is useful when we are working with a large number of motion at a time, like working in loops. So if you increase the speed to any number, say 50, and now if you move this one to any particular value, say minus 350 and with an angle of 40, I believe you did not have even noticed when this one get up there, because that is actually fast. And if I do this one 140, there we go with that one. So this is how you can actually increase or decrease the speed of this one. After that one, what about the background? Like if you require different color background. So for that one we have a command t dot cat screen and then pass the parentheses dot bg color, that is denoting background color. There you can pass any color, say blue, there we go with all blue. And let me again change them into white. So I suggest you to write down these commands. Once you remember that, then you will not require, but in the beginning I believe you it's better to have notes, and you can also get these in the notes. After that one, these are about these. Few last commands that are in basics are forward, left and right. So this is, we are actually going to some random points without any much knowledge. In practical, if you want to create any figure, so you did not go at point to point, because we did not require the points of this, the coordinates of this point or this point, or say this point. So for that one, what will we do? We will just move this one into forward or in some directions. So to make this one forward, you just write t dot forward and then pass the length you require, say 300. It will move in 300. Let me also reduce some speed. because that's actually getting really fast. So just speed 1. Now we got in forward direction with 300, more 300, there we go with that one. And now what if I need this one at this point? I did not remember the point of this one, but actually I remember angle like this one is 90 degree, but not the point. So what will I do? I will rotate its head. So you can rotate the head by just t dot left, pass the angle say 90, this one goes upward. Now if you move this one forward, say with 30, this will go upward with a 30 pixel. And if I rotate this one into right, now to touch that one line I require 90 and 90 180 degrees. So 180, there I got this one in opposite direction, face down. And if I do this one with 130, there we go with that one, just a little more. Here I have intersected that line. So that's how you can work with this cursor. So I believe I have told you most of the basic commands that you are required to work with this cursor. And by using these you can create any figure here that you will learn in the next videos. So thanks for watching. This is all about the basics. I hope you enjoyed this one. See you in the next video. Hey everyone, in this video we will learn about that how we can create figures by using programming. So let's move. Here we have the terminal and I will begin with a Python shell, then importing turtle, and I did something wrong. I require turtle as t. So again run that one and import turtle as t. There we go. And now to access the window, any command you can run. There we go with p down. Now I want to do something like creating a figure first by using simple commands. So for that one I am taking this cursor right down up to here. So this one, first pen up, and now this point is actually before the x-axis, because this is the, if we take this one origin, this is positive x, this is negative x, this is positive y, this is negative y. So this point actually is negative x and positive y. So t dot go to, and that will be approximately minus 250 and plus 250. There we go. Now to create a square here, what will I do? I simply t dot forward into 100 with pen down. There we go with pen down, and let me again try that one. There we go. After that one I will do t dot right to make a 90 degree angle. There we go with 90 degree, 100, and I will run these commands again, but I did something wrong this time. T dot left, I pressed that one twice. There we go. Now again forward, then right, again forward. There we go with a square. So this is how you can create a square, but it requires a number of lines. So to show that one, what we will do, we will use loop in this one. So simply for a basic for loop, and now we do not require any kind of parameter or anything in that one. We just require to run these commands 4 times, 1, 2, 3 and 4. So we simply take a variable I. So for I in range 1, 2, let me write that one again. For I in range 1, 2, 5. And what will I do in that one? I will add these commands t dot forward, and then I will pass there say 200, a bigger square this time, and t dot right 90 degree, and there we go with a square there. Let me make this one a little larger. So you can notice this one, a square, by just using 3 commands, and that require a number of commands. So what I need to tell you here is you can use the loops to create any kind of figures. Let me show you some others also. First, t dot pen up, and then make this one to go in center. So t dot go to 0 0. There we go with that one. Now to create any circle, what you need to do, first pen down and change the color, say red. And now to create any circle, you just need to write t.circle, because you cannot do moving a point 180 times. So you just need to do t.circle, and in parentheses you need to pass the radius, say 20. Then it will create a circle of radius 20, and that is actually a circle, but it seems to be a non-circular figure, because if you zoom this one, there are edges there. But still, we consider this one as a circle, and you can create this one with any radius like this. And you can also try things like, first let me change this one color to t.color, say blue. And now for I in range 1 to 181 up to 180, t dot circle, in that one pass I. If you do that one, it will create 180 circles, one above the other, and with increasing of 1 with each radius. So this is something I have done that I did not have to, because it will take a little time to create 180 figures. So I'm pausing up the video for a little time, because at this point it has only reached up to 25. So here this one actually done, and this one takes more than 15 minutes I believe. The thing I forget here to increase the speed, that's why that's very slow. If I had done this one like, first let me change the cursor to any other position, say t dot go to and 20 minus 30. There we go with this one. And t dot color red, and increase the speed, t dot speed, say 100. And if I run that loop again, let's try that one again, but not 80 this time, just 90. And there we have t dot circle I. And if you can notice, this one increasing very fast, and this one has taken this time at 100 speed, so that's something we can accept 15. After that one, you can also change these circles, like let me have this one first again to any other position like this one. So this is positive on both sides, so t dot go to, say 150 and 150, a little more, 250 there, that's enough maybe. Now you can also change that loop, something like, let me first out of that one, just 10 values here, and t dot circle I, and pass here t dot left, say 10 degree for each. And then you will find this one, but that's very small. And circle I plus, let me take a particular value first, 90 say, and then pass this one here. There we go, like this one. So you can create these rings also, that looks like a 3D structure, one above the other. So these are the figures you can create. One more I want to show you with this one is, say t dot go to, and this position approximately 150, and on the y-axis this one is approximately minus 250. So there we have this one here at this position. Now what I will do, I will have another loop in which I have 10 values, and instead of this circle I'm going to create a star. So how can I create a star? Simply t dot forward with say 150 degree, and for creating a star we generally use an angle. So t dot left, and that angle will be say 135 this time, and there we go with that one. So here a star like this one is created. And to increase the number of these stars here, like this one has 8 corners, so it means 4 particular one, 4 are their opposite one. So you can use the formula 180 minus 180 divided by the corners you require there. Like here we have 4 main, then by 4, this one equal to 135. So the number of columns you require, according to which you can change the angles here. So that's how you can create these kinds of figure, and this is the basic about creating figures. In the next next video, I will show you something like creating a robotic figure by using only these. So thanks for watching. See you in that video. Hey everyone, in this video we are going to draw this kind of robot by using our skills. So here, this is a very easy task, I believe. So if you are feeling comfortable with this one, I suggest you to pause the video and give it a try. Otherwise, go with me. So I'm taking this one here for a little view so that we can have an idea. And after that, here we have the terminal. And we will begin with Python 3. Now before getting to this robot, few things you need to notice here. If you notice on the robot carefully, then you will find that every part of this one is a rectangle, like this body, the feet, the legs, this head, even the eyes and this pupil inside them. They are also rectangle. So what we need to do here is we need to create 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 rectangles. So we require a number of commands for creating rectangles. So what I'm going to do here, I will define a function that will create a rectangle for me. And the thing here is every rectangle has different length and breadth. So I will take inputs for these values and provide the function length and breadth so that the rectangles will be created. Let me show you that one how. So first of all, import turtle as t. There we go with that one. Now I'm going to define a function known as rectangle. So here we have this one, or give it a short name so that we do not need to call this one with a large name. So here we have this one rectangle, and what I need to pass this one length, and I'm taking the length as horizontal because the cursor moves a distance for this one, that is horizontally. And for the breadth, the vertical distance, here we have this one. Also we have different colors for different rectangles, so I need another one known as color. There we go with this one. Now what will this do? First of all, creating the rectangle, that part is very easy. Just I need to create this forward direction, upward direction, and then again these two, and then fill the color. But for that one, first I need to make my pen down, because this time we cannot do pen everything with pen down, because that will create unnecessary lines here and there. So we need to again and again pen down and pen up. So first of all, I'm making my pen down, then providing a pen size. Sorry, it get capital. So t dot pen size, and taking this one as just 1. After that one, I will provide these colors, that which kind of color does this one fill. So t dot color, and that will be input this one, so col. After that one, I will fill that one. So maybe we did not have used this method. So this method is used to fill color inside these figures. So till now we have just created figures, but we do not have filled color inside that one. So that's how you can fill the color inside the figure. First provide that one a color and then fill inside that one. What happened there? I got out of the function. So again need to create that one. There we have pen down. There we have pen size and the color. After that one, we'll write here just begin underscore fill and pass the parentheses. That's about this one. After that one, here we are done with things like we just need to pen down the size and the color. Now we will create the rectangle. So what will I do? I will use a for loop for I in range, and I will only take here 2 because in square we didn't require to create the same step 4 times because the lengths are equal for every side, but in rectangle only the opposite lengths are equal. So I will first create length, then I will create breadth, and I repeat the process for these 2. I hope you get that one. So first of all, I will create length by t.forward, and this length will be horizontal. After that one, I will change the angle by 90 degrees because rectangle also have 90-degree angle. After that one, I will make this one again in forward. So now first this length is created. Now this has cursor has upward direction and it will travel up to vertical distance. There we have this one. And then I will again rotate this one with 90 degrees. So t dot right, there we have 90. In this way, our rectangle will be created. Now, as soon as the rectangle will be created for everything, then the every figure, like if we consider the foot, then for only for foot. Then here we have begin the fill color. Now we need to end that one. Otherwise, the whole screen will be covered with that color. So end fill, and after that in the end we have to up the pen. So pen up, there we go. And I hope you get this function how I have created this one. Just first pen down, then I have taken a size and color and started filling that color. Then I have created a rectangle by using twice this one. So I have just used loop for 1 and 2. And in each case, first it will go horizontally, then change the angle by 90 degree, then vertically, then again change the angle and then repeat the process. After that one, I have just ended the fill and lifted my pen. So here we have just defined our main function that will create rectangles for us. And now we will move defining this robot. So first of all, t dot pen up. First I will begin with pen up. Here we have this one and go to a specific position. So I did not require any lines there. Now this one, go to that point. I need to make some space here. This one here, and our main product will be here on the left. There we go. So first of all, I have just pen up lifted and then a speed, say not slow, let's take slow first. So here we have, where I get that one, there we have the speed again. After that one, first thing here, if you notice the background color, so that's something like Doja blue. So first provide the background color. So t.bg color, and by this way you can also provide this screen the color. Pass DODGER and then blue. Hit return. There we have the same screen. First step done. And now we will begin from this point, creating the foot first. So t.goto, and the points here will be, I have already found the coordinates. So I'm just writing that coordinates 100 and that one is -150. So it got there. After that one, we need to call the rectangle function. Here we have this one, rect. So rectangle, and there pass first the horizontal distance. So this one is approximately 50 pixels. and the height of foot is 20 pixels, and the color there it is blue. So blue, there we go. So here we got a little rectangle with blue color. So that's how you can create these kinds of figures. After that one, I'm copying the goto command. t.goto. Let me copy this one now. Command C. And the second foot here, this will be on the same y, that is minus 150, but the x will be different, that is minus 30. So minus 30 and minus 150, there I go. And then create the rectangle with the same horizontal distance, same vertical and same color. So there we go with the another one. Now here we are done with this one. After that one, move goto to a different position, minus 25 and minus 50. There we go, that one for this line. After that one, rectangle with a horizontal distance, because these are not very large in horizontal but large in vertical. So horizontal 15 and vertical 100, just 100, not 150. And then provide this one gray. Hit return. There we go with that one. Now again go to command. Y will be same, but X will be minus 50, minus 55. And the same rectangle there. But we got a difference. That must be a little here. So what we do now? We will just create the rectangle, or what will we do? We can do same thing and change the color to Dodger blue. So it will retrace that rectangle, and there we go. So now the gray color rectangle is removed, and we need to go to different positions. Say this one, maybe minus 50. And I believe we are at the right position right now. Change this one to gray. No, again a wrong position. And that must be, if this is minus 50, minus 55, then it must be 60. So 60, and try again the gray. Again a little difference. And this time I'm going for 70, not 70, 65. That's good. And finally we got the perfect legs here, but still more gap, just 5 pixels if you want, but I'm taking this one. You can just pass here minus 70. So here we are now done with that one also. Now move to body, and I have right coordinates for this one. This will not happen again with the coordinates, that is minus 90 and 100. So I go to this one, and now I will create the rectangle there. So the coordinates for these are a little different. This is 100 and this is going to be 150 and of red color. So 100, 150 and red. There we go. So we have now body also. After that one, let's move to another coordinates. That is this one, minus 150, and this one 70. Here I go to this point for this arm, and then I will create a rectangle with gray color but with different values. That is this one 60. Also you can make your robot according to you, more healthier or more thinner if you want to. There we go with that one. Now another position, this one 110. There we go. After that one, the rectangle, and this is going to be a little smaller, that is 15 and 40. There we go with the upper. Now this side. So for that one, here we have this one 10, and this one 70. There we go to that particular position. Now again a rectangle with 60, 15 and gray. There we go. And then this position, that is 55 and 110. Sorry, not that one, just 110. There we go. After that again a rectangle with 15, 40 and gray. There we go with that one. So here we are now done with this one also. Just the upper body is left now. So now let we cover that one. First of all, you need to go to -50 and 120 for this little neck, and then create a rectangle that is also with gray color and with the dimension 50, 20 and gray. There we go. Now just the face. For that one you need to go -85. So I have not remembered this coordinate, I have just written them in notebook and I'm looking at that one. So there we go. And now the rectangle, there we go, 80, and this one 50, and there we have this one red. There we go with a perfect face. After that one, the eyes and the mouth. So first we cover eyes. There we have the coordinates 60 and 160. There we go with that one. After that one, we will create a rectangle there with 30, 10 and white color. There we go. Now we are done with this one. Just these small eyes. So they have coordinates -55 and this one 155. We got that one. And small rectangles with 5, 5 because they are just squares, and this one black for the pupil. There we got a perfect one. And now this time distance must be taken very carefully. 41, 55. There we go. So we have a perfect eye. First I have drawn this one, I have created the eye here somehow. After that one, just the mouth left, that is 40, 155 this one, and then that one is 65 and 138. There we go. And just a rectangle with the same width but different length and same color. There we go. Now we have done with this one. Just hide this cursor. So you can hide this cursor by just t.hide turtle. There we go. So here we are done with this one. We have created a robot same as like this one. That's also I have created with this way. So that's how you can create figures by using your own basic simple commands, but just taking your mind to a different direction. Also, Atom is now working with fine terminal, and you can also make this code with the Atom. Here I have this code. I am just opening this one here, and if you notice, everything is same here. First I have imported turtle. This time is I have just done, because while you will create this function with other editor, it will just once draw the function and it will get closed. Let me show you that one. When I did not add this one, this command, rest the commands are completely same. Turtle, then I have this function, same function but with rectangle name. Then I have first created the foots, then these legs, then the body red, and then you can notice this one, all the things are same but just line by line. So I have saved this one and going to run that one here. Just exit. There we go. So cd desktop Python3 and what's the name, 1.robot.py. There we go. So here this will continuously create our robot without any lag there, but just take a focus at this one. There we go with just face and eyes mouth. There we go. But as soon as this one get over, the application is closed automatically. So for that one, I have added that command here. That is, I have imported a time library, and as soon as the figure is completely drawn, I have made the application sleep for 10 seconds. So it will remain there for 10 seconds and then it will go up. I am showing you for a little of 3 seconds. So I have taken the 3 seconds and increasing the speed to say 100, so that we did not have to wait for that one to draw. There we go. Here we have the robot. So 1, 2 and 3. There we go. So that's how you can do this one. So I am just making this one slow for your code, and this one 10 seconds. And this code will be available with the module, so that you will get, if any error, then you can correct that one. So thanks for watching. We are done with this one. I will see you in the next video. Hey everyone. So in the last video we have drawn this one robot. Now I need you to modify our program so that it will look like this one. Alcoholic robot. They actually drink. So you need to create here 2 arms and these eyes. So whatever these skills we have learned for, I need you to use that one and create that thing. So pause the video for a while, and if you get that one, then perfect, and if you did not, then resume the video and go with me. So I hope you get that one. And now I'm closing that particular one, and here we have the atom with our code robot.py. Now you just need to have some changes here. First we will move with the eyes. They are actually same eyes but just misplaced from the position. So this one, these two are actually the eyes there. So what will I do? I will just change the coordinates with this one is -60 and 160. So -60 and 160. And then lower one is just 5 pixel displaced from its actual position. Save this one, and there we have the terminal. Welcome back terminal. Now this one already on desktop, so just run the file Python3, and then we have one.robot. One more thing, here I have the name one.robot.py. This is the one you are going to get on your module, but with a different number, maybe 300 approx. But the thing there is, don't make the name of the file with turtle.py, because that will not work. It will show you some error. So prevent taking the file name as turtle.py, and also prevent taking spaces in between them. Hit return. There we go with that one. But I'm not going to wait for a long. So this one fastest, or just 100, not even 100, 150. There we go. Run that again, and there we go. Now we have eyes displaced but a little far, so just a little change in eyes. And where we have the eyes, this one -60 and 165. So that's actually displaced on the y-axis. So I'm taking 5 pixels below. Save this one and run it again, and there we go. Now we have the eyes perfectly matched. Now what you need to do with this face. So how can you make a face like this one? So if you get that one, then I believe that you have used the right angle command, in which we just move our angle to any particular one. So there we have this one, the mouth that we have drawn this one. So what will we do? We will first make this one a little down, and then add a right command here, so that it will just slightly go up, and then it will make an angle with that one, and taking that angle 5 for instance. And now run it again. There we go. There we have the face also. Now what about the arms, hands? Now if you have solved this one, then I believe you have done something like creating a rectangle, this one, then this one, and then this one, 3 rectangles there, or generally 6. So you have used here approximately 12 commands. But what you can also do here is, in the last video we have done something like when I have drawn a wrong leg, then I have drawn another one there with the same background color. So what you can do here is just draw a square with this one and then remove this part by drawing another one inside that one with Dodger blue color. Let me show you that one. Now after this one, I will add t.go2 and I will go to a particular position for drawing these hands, and that are going to be minus 155 and 130. There we go. After that one, I will create a rectangle there. So just this rectangle, command C and command V, copying this whole line. So change this configurations to 25 because I'm creating a square there, and this one green because that's actually a green color. And if you run that one now, you will have a hand like this one. Now what will I do? I will remove this portion from here, like this part, so that I will have a hand like that one instead of creating 3 rectangles, and maybe their height and width may vary, and increasing the speed up to 250 or faster. Now here just I will go to the center of this square, not center, approximately 2 by 3rd part of that square, and the coordinates for that one are here minus 147 and that is same 130, and there I will create a rectangle, this one, command V, and that is going to be a very small one, 10 pixel there, 15 pixels here, and the color will be, so if you know the background color, that is Dodger blue, then very good, and if you don't know, then just do t dot background color, so it will automatically take that color. Save that one, run it again with 250 speed. There we go with that one, but a little edge there. So that's actually not the edge, that's our cursor at the end point, so that's just finishing that up. Now we are done with this one, and do same for the another side with different coordinates. For this one green, I'm going to have 50 30, this one only 30, these are same, and then these coordinates 58 and 30. There we go. Not 30, they are actually 130 because this one is same. Save this one and try to run. Here we have this one, go. So one perfect, another one perfect. So we are done with that one perfectly. Now just this cut, like I believe you are noticing this one, this cut, that's just the cursor. So you can just do t dot hide turtle, pass the parentheses, save that one, again run, and wait for that one. It's very fast this time. There we go. Now the perfect arms. In that picture also it's cut actually because that's the cursor. Like if I have this cursor right here, then it seems to be cutted there with a black color. Now we are done with that one. You will find this code also with modify robot.py and check whether your code is correct or not with this one. So thanks for watching. I will see you in the next video with some more interesting concept. Hey everyone, I hope you enjoyed creating the robot. So until now what we have done is all based on static objects. We have created the objects that doesn't move, that remain at their position, and when the drawing is completed they just like that one as the robots. But from now we will begin with some motions. First we will do define motion, in which we just define this one and the data will create it according to that one. Say I have first example, this one kaleidospiral.py. When I run this one, but this is a little wrong, 3.kaleidospiral.py. Hit return and I will get something like this one. So here one by one rings are created with different their radiuses, or we can say diameter, and with different colors one by one. And if you notice this one, they are also changing their actual center position. First the center is there and it has now reached there, which is nearly out of the first main circle, and it will make a ring like this one and continue to build like this one. So this is a first example of a movable object, and this is also actually like a 3D object you can create with that one. Once it get there, it will look like a 3D object. So if you are comfortable with creating this one, then you can create this one by just pausing the video, and if you are not, then follow the video with me and try to create that one. So now if you notice this one, then it's a little harder to tell that whether this one is above or this one is above. So whenever you notice any of the ring, then you cannot tell which is above the other. So let's begin with this one to how to create that one, because this one is not going to stop. Now first we'll clear the terminal. We will begin by just importing turtle. This time I'm not preferring the terminal, and import this one as T, not the temperature. So there we go with that one. After that one, you remember that how we can create a circle. We just simply do T dot circle. There we have this one, and in that circle pass the radius. There we have 5, and if you do that one, you will get a circle like that one, which is stopped there. So let me also import time as T, so that it will not stop there, and T time dot sleep, say for 2 seconds for now, and hide the turtle last. So when I run this one, I got the attribute circle time module. Sorry, I have imported both with the same name T. So time TI, this also TI. Run that one. There we go with a circle. So that's how you can create a circle. Now in that one, you have noticed we have a large number of circles. So what I'm going to do, I'm first going to define a function with the name circle. So here we have this one circle, and then pass the parameters, which I'm not taking anything right now. What I will do there, I will first t.pen color, and that will be, say, I'm taking red for an example, and then create a circle. Here I am not taking the pen up and down inside the function, because that's what I just required once, because the loop will never stop. After that one, size, say this time 10. After that one, there we have this one just, so I'm going to draw this one, call this one here circle, and run this one here. You will get a red color circle with radius 10. So that's how we can have a function here. Now if we remember our main Kaleido spiral, then what in that one is circles with different colors and with different sizes, and that are moving forwardly with a particular distance. So how I achieve that one? So first of all, few basic things I need to add. First, I change the background color to black, because we have black in that one. There we go with black. And then we will set speed to say fast. So maybe I have not mentioned this one. You can also use slow, fast, fastest, slowest here instead of numbers if you cannot define the actual speed. Then pen size a little thicker this time, say 4, and then we have the circle. Now what will we change here? First I will try to move my circle a little. So t.right with a particular, say, value 5. But one thing, when I create this circle, then that will be created only once. So how I can move my circle? That's the point here. So here we will use a concept known as recursion. That's something, if you are belonging from computer science, then you're already familiar with that one. What that actually means is, that's a very simple and basic concept. It means calling a function inside a function. And that means is, first, if I have created a circle by using a function, then in the end of that particular function, I will again call that function, that is circle. Same function here. Then it will again draw a circle. Let me show you that one. If I just do this one and run that one, there this circle is created again and again. It will never stop because I am calling the circle again and again inside that one. And if I add this command here, and now let me first cancel that one because it will continue to run. And now when I run this one, I have this circle again and again, but there is actually a little shift on that one right now. If you have noticed, this is no longer a circle. It is actually moving a little difference in forward direction and then again creating a circle, or we can say the edge is moving, and it now looks like a peach right now, and then it becomes a heart there. So that's how you can again and again call the function inside that one, so it will look like it's actually moving. And that's how you can have a particular right there, so that it will move a little there. Now after that one, here these three things, what I'm going to do with these, I'm letting these to user. So I will just provide this one as an angle, this one, this circle with a radius say size, and the color say color. There we go. And pass here the color, then we have the size, and then we have the angle. There we go. And here I will provide these things, say red. After that we have size, say this time 20, and say shift be 40. Let's see what will happen this time. When you run that one, you will get this one, but nothing after that because the size will be very large. Now few things that we need to change here is, first thing, you also need to pass these there. Maybe that's why that actually doesn't work. Let me try this one right now, because the parameters are not passed there. There we go with that one. So the actual output I'm looking for. So what's happening actually there? It's again calling the function with the same parameters. In the last we did not have passed parameters here, so that actually stopped. And this time we are getting a very beautiful flower here, but we require a little large size for this one. Now this is only red color, but our kaleido spiral is actually in different colors, so the colors are changing at that point. So how we can change the colors for that one? One option is to change the colors by just inputting. Second option here is by using a cycle. That's something I have already searched for. I'm taking a variable here, colors, and that will be, first I'm just passing a cycle here. I will tell you what that is. That's actually going to be a list containing different colors, say red, blue, green, yellow, orange, say gray, few more if you want to add, like purple, pink, and whatever the color you need there, you can add. So this is now actually a cycle. And how a cycle works is, it will take one by one again the values from this list. So this is a concept we have not learned yet, but that's actually how it works. And here this is actually a method, cycle method, and this method is not by default in the main, so we have to but the actually library is by default. We have to import that library, and that is in iteral tools. So what I'm going to do here, from iter tools, import cycle. There we go with that one. So now I have imported this cycle, and in color What will I do? I will just write next of the cycle. So next of colors. So in this way it will change the values one by one with that one. Now save that one and increase this size to 50 this time, so that we can notice that one much better. It is actually again and again running. Now run that one again. There we go. Red, blue, green, and if you notice, this is actually our list pattern: red, blue, green, yellow, orange, gray, purple, pink, and there again this one, that is the flower created, and the colors are changing above one another. So now that is actually first red, and you can notice this one. And if you provide this one a same color, only one color, then it will now look like a flower, but not the flower. Let me move to our next modifications. After this one, our next modifications is, if you have noticed, our first circle is very small, then the second circle is a little larger, and then again and again they are getting larger. So how can I solve that problem? That's something looking weird, because we cannot just call this one with by increasing the values here again and again. But what we can do, when the function is called inside the function, then it will call a little modify function from that previous one. If you remember loop, like for I in any number, say range we are using, then what will we do in that one? We increase I equal to I plus 1, and there the I is increased by 1 every time it get out of that loop. So we are going to use the same concept here. We will change the size and the angle from the original one to the next one. So size will be size plus say 5 each time, and the angle will be a little one, say 1. And now we do not require the color here because we have used the cycle. Save this one, run that again. Sorry, I have passed the red here. Before I got that one. Now there we go. Red, blue, green, and if you are noticing, now we have the orange one and gray one, even double of red. Purple, blue, gray. This one is even double of that particular blue, and this one is increasing again and again. So we are getting actually a very beautiful figure, that is a growing flower, but still we require some modification in that one. And what the last modification left here is the rotation of this one, this actual center of this flower, and that is actually the edge of every circle here that need to be moved. So what will we do for that one? We will move this one a little forward. So forward, there we go. Pass this a value first 5, and in that one also forward plus 5, and change this one for something like forward here, and pass another parameter. So because that one also need to be inputted, and that's why we have not considered that one before, and provide a value in the beginning, say 1 or just 0, because the first one need to be in center. And there we have this forward. And now let me try our program again, but it's actually still running down, so these circles are very large enough now. Go to that one again, run. There we go, this time the one that we required. So here we have our main output that we are needed there. Actually that is moving from its particular position, and there we go. So that's how you can have this spiral, sorry, but this time they are moving a different one. You can also have the same values like the one that we have in our example. So for that one you need to pass here the size, a smaller one, say 30 first of all, angle will be 0, and the forward direction take 1 in the beginning, and let me try that one right now. There we go. So this is the one that we needed, but actually it is moving from that point and now going circularly, and this will cover a loop right like this one. So this is nearly equal to the one that we have in the beginning, and that is going out of the figure. So that's how you can create these things very easily. In the next video we will do some modifications with that one, and see you there. And let me also show you what we are going to do in the next video. So that will be going to be our second py file, this one. So let me run that one here, Python3 space 4.keleido loop.py. Sometime I thought that why I have their big names. So in the next video you are going to make something like this one, a circle, then a square, then again a circle, square, and the same pattern like the kaleido spiral is going on. So if you are feeling comfortable and if you can make this one, then give it a try before watching the next video. And if you are not feeling, then go with me in the next video. We will continue with this one. So see you there. Hey everyone, so in the last video we are done with the kaleidos loop, and that is a little more in forward direction that we have not focused on this one. So if you like the demonstration, just change this one to 1, and then it will work like the original one. And you can also check one by just running that one. Now we just talk about kaleido loop in this one. So that is something in which we have first a circle, then a square, then a circle, then again a square. So that's actually very easy, and there are a number of concepts you can do with that one, but I'm going to have a basic one. What I will do, I will take another parameter in this function, that is my shape. And if that shape, I will check that thing, that if that shape is circle, then first draw the circle and change the variable into square. And then if that is square, draw a square and change the variable again to circle. That is really very easy. And how I will do that one? First I will take a circle in the beginning and pass here another parameter shape. Rest the things there are same, we just need to change this function. And what will I do? First I have the colors will be same like this one, and then remove these commands from here and begin with the variable that is next shape, which will define which is the next shape I'm going to have. And first, if the shape equal to circle, so in that case it will just draw the circle, t.circle, and draw a circle with this size, so t.circle, and pass this size and change the next shape into a square, so that will become square. There we go with that one. And else if, or we just pass there, that particular figure, that is our shape, equal to square, then it, in that case what we need to do, we will draw a square. And how we'll do that one? So for I in range, simply pass 4 there, because for square we require to repeat the process for same, so t.forward, and the size will be size multiplied by 2. We are taking example just, then move in left with a 90 degree. So there we go with creating a square. And then what we'll do, just change the next shape into circle. So I hope this is very easy and you have understand this one very easily, because only there are few commands. And then after that one, we require the forward in the right direction. So t dot right and then angle. After that provide forward motion, and that is going to be this one, forw. So forw, and here just pass next shape, so that our shape will equal to next shape. So if you run this one, what's the name of this one, kaleidospiral.py, we have modified the last one. There we go, a circle, square, again a circle, square. Now this time we have also the perfect motion here, and that is looking very nice, and they will continue to run there again and again. So that's how you can modify this one very easily, and you will also get this one as a separate code. If you get any error in that one, just open this one with atom and check your code. Also don't click on these .py files, just double click, they may start to run. So thanks for watching. This is about this figure, and this one going to be very great here. See you in the next video. Hey everyone, so in this video we will create a moving turtle that will move on this window and will look like something this one. Here this turtle moving here and there randomly and changing its direction by itself. So few things noticed here, like it is moving in a fixed boundary, and second is its motion that is random, anywhere it can move. So these things we need to focus, and let's begin with that one. So let me first clear this one. There we go. After that one we will import turtle as t, not the temperature. There we go. After that one we will import random as rd for random motion. Then we will import time as ti for a while, and after that one just add ti.sleep, say for 3 seconds. That's enough, I believe. After that one, if we talk about the turtle, then it seems that creating the turtle is very hard, because that's a animated figure, but that is a by default figure. So you can just simply create this one, t.shape, and pass there just turtle. There we go. If you run this one, there we have a turtle here, and that is look like the actual one. After that one, the one we have noticed is green and this one is black, so we will make this one green. So t.fill color and pass there green. Now if you run that one, there we have a green turtle. After that one, if we talk about the background color, then in the demo that will be a black, so make this one black. And now if you run that one, you will have a black background with this turtle here. So we are done with this thing. Just last speed of that one. So turtle is slow, so pass here slow. After that one, we will move to defining the boundaries and defining the motion. So let's begin with that one. First the boundary, that we have that one as inside underscore window, denoting the inside window. So what actually I will do here, I will define right, left, top and bottom limits, so that will not get out of that one. And how will I define that one? As you know that the center, this point like this one, is the center of the window when that appears here with turtle graphic. Then here we have some distance on the left, on the right, on the top and bottom. So what we will do, we'll first get the left and right, top, bottom distances, and then make a boundary of taking like 100 from this one, so that it will not get to boundary. Let me show you that one, then you will understand that better. So first of all, I will define limit, and not only limit, left limit. There we go. And how will I define that one? First of all, getting the size of the window is very easy. You just have to do t.window underscore width for width and length for the height. So I'm just taking the width of that one and pass the parentheses there. So that's how you can get the length of your window. Now the left portion of this one is the half of the total width. Like if I have point to point window, then the half of that is the left one, because we have the center at the center of the window in case of turtle graphics, and the left distance is also -1. So this is actually the available length at the left side. What will I do? I will make 100 from the corner. Like if I assume this one as 100, so this is total minus 100. So what will I do? I will subtract minus from this one, but actually the distance is in negative, so I need to add here 100 to reduce from the boundary a distance of 100 pixels. That's about the limit. Now it is very easy to add others. Say this one right, not wrote, it's right. There we go. This is going to be positive, so I need to subtract 100 from that one. I think you understand this now. Then I have the top limit, and that is going to be actually the height, not the width. Also that is actually positive, so I need to subtract this one because upper side is positive, and also this subtract. And if I talk about the bottom one, that is this one bottom, that is actually going to be a negative distance, so I need to add 100 there. I hope you understand this one, creating the limits. Now I will take X and Y, and these are the actual positions of our cursor at that particular location, or say our turtle. And how will I get them? Just simply t.position and parentheses. That's how I can get the position of X and Y. Now I have the position of X and Y and the limits. What will I do now? I will take a variable inside that tells me that actually the turtle is inside the window or not. If it's inside the window, then make the program run, otherwise come back. And that will be actually, what does inside mean? That is, it is greater than the left distance, lower than the right distance, because if it will be somewhere around these where I'm moving my cursor here and there. So it's actually greater than the left one and lower than the right one. Similarly, greater than the bottom, less than the right. So just left underscore, and this will be going to be a boolean. Actually it's just only true or false, that it's actually inside the window, true, not, then false. So how will I define that one? So it will X, in that case the positions X is greater than X limit and less than right limit. So here we have right limit, and our Y greater than the bottom, less than the top. So bottom limit and then less than the top limit. There we go. I hope you understand this one now, because this is very easy and clear. And then just return inside. There we go. After that one, we will define a move function. Define move. This will actually move our turtle. So move underscore turtle is much better. There we go. But name has no effect. After that one, we will check here whether it is inside the window or not. So if it is inside the window, then it will actually move our turtle. Else it will take our turtle back to the window. So how will I do that one? First of all, when it is inside the window, so I will actually do t.right, and there I will pass just an angle at which it has to move, and then I will make it run forward. So forward, say 200. You can take any distance, and a task for you, make this distance also random. Now if I specify the angle by my own, that it will always move with a particular angle, but I don't need that one. So what will I do? Inside the if condition, I will define the angle, as a random value between 0 to 180 because they are the possible angles. So angle will be, if you remember creating the random values, we have this one rd dot rand int, and that will actually be in between 0 to 180. So by this I will get a random value. That random will be its move angle, and then it will move forward. So similarly you have to make this forward distance as a random value. So I hope you will get that one, just a distance variable, and convert that one also into random. After that one, if it is not inside the window, if by mistake it get out of that one, so in that case just move backward with say value 200 so that it will get back in our window. After that one, I need to call the functions. So while it's true, while it's inside that one, so in that case just move turtle and pass the parentheses. There we go. Whenever that is true, just call the function. Remove that one and cross fingers, run the program. There we go. So it's actually moving 200 distance and random values. I hope this one is very easy and also easy to understand. So you can also play with this one, but nothing to play, just look at that one. Also, if you want to make this one random, just you need to pass here say distance rd dot rand int, take between say from 50 to 300, and pass this one here dist, save, and now when you run that one, you will get this one moving with different distances. So that's how you can create this one very easily. And also in that case, make the backward distance to maximum 300 so that it will not get lost. So this is the code you will also get to check the errors whether you have any or not. And also this time is not required now. So this is all about this one and about the turtle graphics. More you will understand the motion while we work on the projects where we require to move the figures with the keypad. So wait for that one. I hope you are excited with that. So thanks for watching. See you later.